Okay, in this video I want to use the unit circle to find the sine, cosine, and tangent of the quadrantal angles. First thing we should do is talk about the unit circle and how we can basically use the unit circle to find the x and y coordinates that go with the endpoints of the hypotenuse. So I want to sketch a circle. I'm going to let the radius be 1, which makes it the unit circle. So let me sketch a hypotenuse in here. We're going to call this the central angle. And also we want to visualize that we have a right triangle. So we want to find this x, y coordinate that goes with this endpoint of this hypotenuse, and for this circle we want to use a unit circle which has a radius of 1. So if I want to find the x point, this x distance is actually this x coordinate here. This y distance is this height of the triangle right there. I've got a hypotenuse with an adjacent side if I'm looking for the x. So to find the x, I'm thinking about adjacent over hypotenuse, which is a cosine ratio. So cosine of the angle is the adjacent side over the hypotenuse. And the y coordinate is going to be opposite over hypotenuse. So the y coordinate is going to be the sine of the central angle equals y over the hypotenuse, because y is the opposite side. When I multiply both sides by 1, I get that the cosine of theta is the x coordinate, and the sine of theta is the y coordinate. So if I come back up here and I label these 2 points on the circle, the x coordinate is given by the cosine of the central angle, and the y coordinate is given by the sine of the central angle. And this is just a general right triangle. It works, this idea works for any triangle anywhere around the circle. What we have to think about though is this Astc pattern as we get into the different quadrants. In the second quadrant, sine is positive and cosine is negative. So we would basically do the same type of idea, but the cosine would actually be a negative because you're dealing with a negative x. Down in the third quadrant, cosine is going to be negative and sine is going to be negative. So cosine and sine are both going to be negative, which kind of matches with, negative x, negative y. So you can verify that as you work your way around. Okay, we need to talk about how we can use this to find the values of the quadrantal angles. So what I want to do now is visualize that I have another circle, and now we're just going to talk about angles that are multiples of 90. So we've got a 0, we've got a 90, we've got a 180, and we have a 270. As we keep going around in the positive direction, add another 90, we get to 360. Add another 90 to 360, we get 450. Keep going, 540, and so on as we go around in the positive direction. Also, if we're going in the negative direction, with this being a 0, negative 90 would correspond to a positive 270. And you can think negative 90 plus 360 gives me 270, so they're coterminal angles. Plus, because they're multiples of 90, they're quadrantal angles. Take another 90 away from negative 90, I get negative 180. This is negative 270, negative 360, and so on. So the negative positive just kind of depends on which way you're measuring the angle. Okay, let me move this up a little bit, give some room. So let's talk about the endpoints of this radius. Again, we're going to pretend we have a circle of radius 1. So these are all distances of 1 here, even though they might not be drawn to scale. This point here at the end of this piece of the x-axis has an x-coordinate of 1 and a y-coordinate of 0. If if I go 90 degrees, I've got actually a 0 coordinate because I've got a 0x and a positive 1 for the y. So the endpoint here is going to be 0, 1. At 270, I've got negative 1 up 0, negative 1, 0 for that coordinate. And at 270, I have over 0 down 1, 0, negative 1, and then it repeats as I go around. And then again, the same idea works for negative 90. Negative 90 is going to be down here. The x coordinate is going to be a 0. The y coordinate is going to be a negative 1. So I need to draw this xy cosine sine idea back into this. If I want to find the cosine of a 0-degree angle, I can actually use the x and the y coordinate for the cosine and the sine of that angle. So I could talk about the cosine of 0 and the sine of 0. Let me make that a 0. So for the cosine of 0 degrees, the x coordinate is a 1. So cosine of 0 is 1. For sine of 0, the y coordinate is a 0. So sine of 0 is 0. For 90 degrees, cosine 90, sine 90. The cosine of 90 has an x coordinate. Well, this 90-degree angle has an x coordinate of 0 as the endpoint, so the cosine of 90 is 0, and the y coordinate is a 1, so sine of 90 is a 1. For 180, cosine 180 and sine of 180, using this circle as a reference. Now 180 is back over here. The x coordinate is a negative 1, so cosine 180 is a negative 1. The y coordinate is a 0 at 180, so the sine of 180 is a 0. Let's go to 270. Cosine 270, sine 270. For 270, the x coordinate is a 0, so cosine 270 is 0. And the sine of 270 is a negative 1. So sine of 270 is a negative 1. Now we also can find the tangent. There's an identity that tangent is the same as sine over cosine. And you can verify that with opposite over hypotenuse for sine and adjacent over hypotenuse for cosine. When you divide O over H by A over H, you keep change flip, the H's cancel, and you end up with O over A. So you can verify that. So that means that to find the tangent of 0, all I have to do is take sine divided by cosine. I get 0 divided by 1, which is 0. So the tangent of 0 is 0. For 90 degrees, tangent of 90 is sine over cosine. I get 1 over 0, which is undefined. For 180, tangent 180 is sine over cosine. I get 0 over negative 1. So tan 180 is 0. And for 270, I get sine over cosine for tangent, which is negative 1 over 0, which is undefined. And this also works for negative angles, like cosine negative 90 is, like we saw before, negative 90 is the same as a 270. So the cosine, sine, and tangent of a negative 90 are going to be exactly these same numbers. Okay, that's all for this video.